LOD2, Creating Knowledge Out of Interlinked Data. Welcome to the LOD2 webinar series, Linked Open Data Tools and Services for Publishers, Enterprises and Governmental Institutions. LOD2 is a large-scale integrating project co-funded by the European Commission within the FP7 Information and Communication Technologies Work Programme. This 4-year project comprises leading linked open data technology researchers, companies and service providers. Coming from across 12 countries, the partners are coordinated by the Agile Knowledge Engineering and Semantic Web Research Group at the University of Leipzig, Germany. LOD2 will integrate and syndicate linked data with existing large-scale applications. The project shows the benefits in the scenarios of media and publishing, corporate data intranets and e-government. Once per month, the LOD2 webinar series offer a free webinar about tools and services along the linked open data lifecycle. Stay with us and learn more about acquisition, editing, composing, connected applications, and finally, publishing linked open data.
Hello and good afternoon from my side. I'm Bert from Nuffelen and next to me is sitting Karel.
Hi.
So as Mark already told you, we will introduce you to the LOD2 Stack Release 3. And we give an overview of that, and that will be the first part of the presentation. And the second part of our webinar will be a demo case on showing how we connect those applications together to deal with a special kind of information, namely statistical data. Okay, this LOD2 Stack Release 3. If we look back, then 2 years back from now, we released the first release of the LOD2 Stack, and at that time, we announced 25 components in our Debian repository. Today, we can say that we have 47 components available, of which are 10 new components introduced in the last year. Most of them are available as Debian package, and 24 of them are accessible through the graphical user interface in Demonstrator or the Statistical Office Workbench. The reduced number here just means that there are much more Debian packages that support one single component. If we look back and we create a graphic overview, then what you see here is the stack in release 2. And we hide, and then we show where the 10 new ones are placed. And as you see, there are a number around in the storage and querying part of the LOD2 stack lifecycle, 3 in the extraction area, 2 in the browse and exploration area, and 1 which shares functionality over many aspects. In addition, and this is connected to the second part of the LOD2 stack, we added an integrated workbench, the Statistical Office Workbench, which will integrate components and functionalities from the existing components in the stack together with some special components that we constructed to support much better the statistical data use case. I will explain them in more detail later on. We'll give you now an overview of about the 10 new components. That doesn't mean that the other components that's already existing in the LOD2 stack do not have progressed enough, but I think it's important that we show now what is new and potentially available. So the first highlight is Virtuoso 7. And Virtuoso 7 is different from Virtuoso 6, which is still part of the LOD2 stack up to now. Virtuoso 7 is a column store implementation instead of a row store implementation. This has a serious impact on the query performance. So Virtuoso 7 is outperforming Virtuoso 6 at least 3 times or even more on some benchmarking cases. In addition, Virtuoso 7 improves on loading up datasets and concurrency support. If you want to have more information on Virtuoso 7 and the benchmarking results, follow the links that are mentioned here on the slide. Another package, another component that is in the LOD2 stack and which is new is the RDF dataset integration package. With that, we enable the creation of Debian packages that consist of auto-installable RDF datasets. This is useful for creating dependencies for components that use a particular dataset. And in this way, we can create an easy to install application. A third component is sparqlify. This is an alternative to D2R where you're going to connect to an SQL database system. So it rewrites Sparkle queries to SQL, and it allows you to query in this way an SQL database. A fourth component is SIREn. SIREn is a Lucene Solar extension which materializes the content of RDF data into this Lucene Solar index. And then it allows you to query your Sparkle, your RDF data through this Lucene and Solar interface. And this has well been tied up together with Sparkle interface, and this can be shown in Syndice. So more information is found at the link below. A fifth is the R2R framework. R2R is the ambition is to create a mapping, is a mapping language to map one vocabulary into another. And this mapping rules, these mapping rules can be executed to automate these mappings, to execute these mappings, and there exists an engine in the LOD2 stack to execute these mapping rules. A sixth component is the dbpedia-spotlight user interface. This is an extension of the dbpedia-spotlight engine, which was already part of the LOD2 stack, but this is the front end, and lightweight front end for the dbpedia-spotlight. So instead of having only the engine, now you have as well a front end to the dbpedia-spotlight. A seventh component is the LOD Manager Suite, and this component allows you to set up in a user interface small and easy pipelines to extract data from a various set of sources, transform these extracted data in RDF to new structures, and then load it into your store. So this suite has a user interface. You can follow up these pipelines, they are schedulable, etc., and are extendable. So the pipelines are extendable with your own plugins. So each component, like as you see on the slides, and any to CSV extractor, you can define your own plugins and create added value to it. The eighth new component, and this is a very recent addition to the LOD2 stack, is Facete. Facete is a tool to browse RDF data that has a geospatial information, so longitude and latitude inside the data set. The aim of it is that it first allows you to select a part of the data set of your interest, create a table out of it, and when this is possible, allows you to position this information on the map. And it's a fully client-side application. The last two components, CubeViz, and the next one, the CSV import, will be discussed in more detail during the next part, or the second part of the webinar. But in their own, they are usable and downloadable from the LOD2 stack. So CubeViz is a visualization tool and for statistical data based on that's represented in the data cube vocabulary. And the counterpart is the CSV import tool, which allows you to import tabular data and transform that to RDF. It has a generic support, for converting CSVs, but in this case it has been extended to deal with DataCube. All these components and so on are available through two front ends. One is the LO2 demonstrator, which can be seen as an intelligent bookmark service for the LOD2 stack. So with this, you can browse through all the components, have a quick look, play with it, explore some information, and do some with it. A more integrated integration view is the LOD2 stack Statistical Office workbench, and that allows you to follow a number of these components and to organize them for the statistical data, and this will be explained later. Orthogonally to all these components, we have been working on a layer which covers over all the components, and this is the authentication, authorization, and provenance layer. Authentication, and we have been working to integrate the web ID service and authentication interaction into the LOD2 stack, and we did this integration into the Statistical Office workbench. So if you want to have an example how web ID can be used to interact and to create users, then you can find it in the Statistical Office workbench. When a user is authenticated using the web ID profile, then we have the authorization and so roles and powers for this user, and we have implemented a layer where we can specify based on the roles that some URLs, some portions of the workbench are accessible for a user or not. And finally, we can track the actions of this user, what it does, going from one application to the other application into a separate provenance graph. If you want to have more information, you find everything in more detail at stack.lod2.eu. You find there how you can start with the LOD2 stack, where you can download, how you can contact us to get some support, as well some stack in use cases and online demos of individual components. And finally, we would like that you contribute, if you have components, if you're a component builder, small or big, to the LOD2 stack, and that we use our channel to distribute your work as well. One question, main question that is that for current stack owners and that have a system that runs on release 2 and that want to upgrade to release 3, first remark we have to give is that release 3 requires you to run a 64-bit machine. It's still Ubuntu 12.04, that's the reference operating system, but we require to have a 64-bit machine. The reason is the following. If you do a simple apt-get upgrade, this is the technical package management upgrade statement, it will be enough, but you will move towards Virtuoso 7. That will be the default, and Virtuoso 7 is available only in a 64-bit build. This leads you, when you upgrade release 2 to release 3, to the following situation, namely that you have a conflict with your old or your existing Virtuoso 6 installation. The package manager will ask you questions, will guide you through the transition process, and will lead you to a situation where you have Virtuoso 7 as a default implementation of default store on your system. But best ensure yourself that you have a backup of the content of the database, so if something goes wrong during this process, that you can have your data available. Detailed instructions and ways how to do it that you can find on this link below, and it is accessible as well via the stack.lod2.eu. So as I already mentioned, these are the two main places for information on the stack, stack.lod2.eu and the wiki. We have a public demo of the demonstrators LOD2 demo and the LOD2 stat workbench. And then if you want to have information about individual components or items that have been discussed previously and so on, look to the webinars. For example, Virtuoso 7, there has been a webinar on it. Of course, we are not at standstill, so there will come future improvements in the last year of the LOD2 project. So if there are new components upgrades and have bug fixes, like what we have regularly with Virtuoso 7, we will distribute this. New components like faceted, we will include them. Another one will be ORE. It will be a component that gets a major upgrade in the last year. But we also want to learn from you. Still, even in this last year, we want to learn from you. So if you have experience on using the stack or a single component or a few of the components, we are interested, we want to learn from it, and contact us. There's the email address, you can find us. Or contact one of our partners, that's fine too. Since in 2014, the LOD2 project will end, this would be a risk that it as well means the end of the LOD2 stack. Luckily, this will be not the case. We are at this moment already collaborating with the GeoNome project, and we are creating a project neutral space for the LOD2 stack. And here I defined the URL stack@linkdata.org. So to continue these applications and to distribute all these components in the future. In addition, we already have set up an extra support in this area, namely to support Maven artifacts to be shared across people that have interest in linked data. This concludes the first part of the webinar. The second part, we will show you, in the second part, we will show you how, if we take components together, we bring them together, how we can serve a particular domain. The reason for choosing the statistical domain is embedded in the following motivation. Namely, the data is easy accessible. It's easy to access statistical data in different languages over different detailed domains. It's available. Secondly, inside the consortium, there's knowledge and research interest to do something with statistical data. You see some information here. But if we look to the tool support around statistical data in the linked data context, there's almost nothing available when we started. And what we will present you now is a workbench that will provide support on the following elements: creation of the data cubes, managing of the data cubes, merging and splitting of the data cubes, and in using this framework, we are as well able to explore in a deeper way the integration between components. So the reason, if you look for the business drivers why this is of interest and to look deeper into the statistical domain, is that statistical data in the public sector needs to be published, needs to be made public. And this one way to make it public would be to introduce this into the LOD cloud. In order to do that, all these statistical offices need support and tool support to create statistical data in this new format and to publish it. Of course, if you only publish it, then yeah, in a format, and it cannot be consumed, that's not of interest either. So on the other hand, we need to support the consumption of this data as well in this format. To support this all, we created the Statistical Office workbench, and the GUI is in some sense very important here. Why? Because it drives you through the process of publishing linked data for the statistical domain. And you will see that in more detail later, but we go from managing a graph, from getting the data inside your publishing environment, your managing environment, dealing with it, enriching it, transforming it, and finally publishing and presenting it. And this covers a number of functionalities and that are needed. You need to deal with transformation and conversion aspects. You need to deal with building and querying the data cubes that we have created. You have to validate it. You have to support interlinking of those cubes, visualization, exploration, and the final publishing of the RDF data cubes. Now Karel will give you an overview with a live demo of the Statistical Office workbench.
Okay, well, thank you, Bert. Indeed, I'll give you a demo of the Statistical Office workbench, and in this demo, we'll be touching on a number of stages that are available in the LOD2 stack. This slide shows you the stage that we'll be touching. As you can see, it's almost a complete demo. There's only 2 stages that are missing, the authoring and the enrichment stages. Now, let me show you the data that we'll actually be working on. This is a CSV file that we start with. It shows you a breakdown of diseases along different areas in the world. Now, to make matters a little bit more interesting, we're going to split this CSV file in 2, and we're going to translate the bottom half to a different language, because we started out with English, and we're going to translate the bottom half in French. Of course, this is somewhat of an artificial situation, where this data has been modified to improve the demo clarity somewhat. But it is a situation that you'll find in real life. You'll get different sources of data and you'll have to combine them in some way. That's what we hope to show here. We'll be taking these 2 CSV files that we have in the end and we'll be transforming them to the RDF data cube vocabulary. Now, what does this vocabulary actually look like? RDF data cube is a linked data way to represent statistical information. It's right now it's a candidate recommendation for the W3C, and it allows you to work with SDMX vocabularies as well. Now this slide shows you a graphical representation of a data cube on the left, and then on the right the actual triples that make up the data cube. Well, a data cube is actually a collection of a number of observation entities that are grouped along a number of dimensions. And this can be any number of dimensions. It's not limited to 3, and the dimensions shouldn't be about of equal size, like the name suggests. You're actually really free in that area. Now let's have a look at one of those observations. As you can see in triples here, we see one observation, and the observation has a location dimension value, which is URI, and a disease value, which is URI2. The fact that this is a URI means that you can connect any data that you want to this URI. There's also a value, a measurement value, which is 7,782 in this case. And the observation has a link to the data cube that it is part of. All right. Now, this is the most basic entity in the data cube. There are more advanced entities as well, like slices, where you actually fix the value of a single dimension. And then, for example, in this case, we see that the dimension value has been fixed to the Europe value. And we see all the observations that are part of the slice where the dimension is Europe for the location dimension. All right, that's actually a very brief introduction to the RDF data cube vocabulary. If you want to find out more, you can go to the W3C site and see the entire specification for yourself. There's one more point that I want to touch upon, and that's the merging of these data cubes. We're going to transform our CSV files to data cubes, but we'll still end up with 2 cubes. And if we merge them in a very naive way, you got a picture like you see here. You got the English part and the French part, and even though they're talking about the same regions, there's actually no way of knowing that the regions are the same because they're in different languages. What we need to do is we need to reconcile these values with a predefined code list that we have defined earlier. This code list holds the agreed upon values for regions, for example, and that means that we can make sure that the values that point to entities in English, like English regions, to the regions in French as well. Now, that fixed the problem for regions, but we still have the diseases. We're actually talking about different diseases in this case, but we have one portion that is in English and one portion that's in French. So we'd actually like diseases to have both languages. We can do that too with a code list. Just merge them to the code list, and we get translations in all languages that we want. We can even add other languages or other context information to the code lists too. For example, all European languages. Or, as we're talking about diseases, we can also add symptoms for the diseases or like descriptions of what it looks like. All right, so that's about the reconciliation part. Now, let's talk you through the different components that we'll be seeing in this demo. Of course, we'll be seeing the Statistical Office workbench, but this workbench is actually an aggregation of different, a loose aggregation really of different components. All of these components are tied together by the fact that they're using the same SPARQL triple store, which is in fact Virtuoso open source in this case. The components that we'll be using are CSV import components, some DataCube merging components that we've written especially for the Statistical Office workbench, the Circle linking component, ontowiki as well, actually part of it, CubeViz of course, and well, some other components. But you'll see that in a moment. Let me show you the scenario that we'll be doing. We'll be starting out with the two CSV files that I showed you. We'll be transforming them into data cubes using the CSV import application. These data cubes then have to be merged. We'll use a specially written Statistical Office component for that. And once we have a single cube, we can link it to the code list or possibly other context information that's available. Actually, we'll be using a code list that we've created out of dbpedia information, just something to show you. Once that is done, we have a fully context-aware data cube. And we can choose to visualize this data cube using the CubeViz application. Well, maybe our data cube is even interesting to people who want to build applications with it, and we can decide to publish it to a CCAN instance so that other people can find it. All right, this is an overview of all the stages we'll be going through in the demo. You can find it in the presentation in a week's time. Just a quick reminder of the data that we'll be showing in the demonstration. We are talking about the CSV file that we've got in off, so we've actually duplicated it. We've got the regions of the world in the horizontal dimension and the diseases in the vertical dimension. All right, let me switch to my demo environment. Here it is. To log in first, open the browser. Is. Yes, move it to full screen, indeed. Then go to my local installation of the LOD2 Statistical Office workbench and put this to full screen as well. All right. Now, the first step that we'll be doing is to import the CSV files. We'll first have to select a graph to import the CSV files in, and we're going to create a new graph. Like this. So it sends us a message that the graph has been created and we select it as a default graph. We then have to say that we're going to be dealing with statistical data, so we'll get a data cube mapping, and we have to select the CSV file to be transformed, like this. Okay, click the Import CSV button, and we have to provide some names for the data cube that will be created. Let's call it cube, give it a data structure definition name, some other names that are important. The measurement that we'll be dealing with is the infected population. Like that. And then we have to select the dimensions that are being used in the file. So the first dimension is the region dimension. Here we go. I select all the values in the CSV file. And we do the same thing for the disease dimension. There it is. All right, so now all the dimension values are selected. We still have to select the data range that we're interested in, and we're going to select the entire CSV file. There we go. can now extract the triples, and the data cube will be created for us. If we just wait a few moments. All right, there it is. We can now visualize this data cube. Actually, just explore it in ontowiki first. You can click on the observation entities here and show you some values. We're going to be showing the actual measurements and the 2 dimensions that are available. And we can see, for example, a measurement for how many tuberculosis infected persons are in Africa. All right, now we have to import the second part of the CSV file using the same procedure. So select statistical data, select the CSV file that you're interested in, give some names. Let's call this one Cube2. Still dealing with infected population. Add some dimensions, a region here, but I don't really have accents on my keyboard, so I have to do it without the accents. And maladie, I guess, in French. And still select the data range. Okay, now the 2 cubes have been imported. There it is. And we have to merge them together with our data cube merging component, which asks us for the datasets to merge. Shows us the datasets are available in the current graph, which is just the 2 that have been created. Then asks us in which graph the new cube should be created, and that's a new graph. And also asks for a ULEI for the new cube. Like that. We then select the Merge Datasets button, and we have to provide a mapping for all of the dimensions and the measurements that are available in the cube. So we've done that now. We're going to click the Perform Merge button, and it gives us a message that the cube has been merged. All right. Now we can select a newly created cube as our default graph and perform the linking with the code lists that we've defined. So we've already set up a Silk linking project here. There's a number of different inputs that are coming in. We've got a dbpedia continents code list that we've created from a local dbpedia dump. We've got our demo cube that's been selected, and we've got the diseases code list which we've created. There's also 2 Silk linking tasks, and we're going to open one of them. All right, we see that we're actually having a very simple linkage rule. We're just comparing the labels of the 2 elements, one from the data cube and one from the code list. I'm going to lowercase them and use a string comparison on them. All right, then it's time to generate the links. I'm going to immediately import them in the Sparkle endpoint that we're using. And after a while, we'll see the links that have been discovered by the Silk framework. There they are. First link, for example, shows you that the French version of lower respiratory infections has been mapped to the value in our code list, which actually has 2 translations for this available. All right. Now we'll do the same thing for the regions dimension. There we go. Generate the links as well. And import them in the Sparkle endpoint. Okay. This will update in a moment. There it is. And we see that the continents have also been merged. All right, that's it for the linking part. Now we have to reconcile the values in our dimensions to these values in the code list. So we're going to select the data cube that we're interested in. There's only one in the current graph because we've switched to the merged one. Now we're going to select the region dimension and the code list that is relevant. So that's the continents code list. And then we have to execute 2 Sparkle queries. The first one is going to insert the values in the code list into the dimension values of the merged cube. So we're going to run that. Then we have to clean up the cube by removing the old values that were there, but that were not part of the code list. All right, we've done that, and we're going to do it also for the disease dimension. There it is, first linking, and then cleaning up. All right, that's been done. Our cube is now fully prepared. Maybe it's time to validate the cube. We see here all of the integrity constraints that have been defined by the W3C, and we see that there's actually one failing constraint, which says that the dimension values that are used in the cube should actually, or the dimensions themselves should actually have a range defined. okay, the CSV import application has not done that for us. That's too bad. But we actually know that the CubeViz application can handle this. So we're not going to edit this in ontowiki, although we could. All right, let's actually do this visualization with CubeViz right now. So we'll select the CubeViz component. We see that our datasets have been selected, and we have to select the values that we're interested in. We're just going to go ahead and select all dimension values. There they are. You've seen the graph updating as I did that. And we're going to switch to a new type of graph and do some configuration so we get a nice breakdown of the diseases per continent. This is what you see here. And for example, we see that malaria is a very high, has the most infected persons in Africa. And because we actually have linked Africa to be part of our code list, we can now open the CubeViz legend and we can ask what else we know about Africa, which will open the dbpedia page for Africa. If we wait just a few moments, otherwise we can also show you the information we have locally available in our ontowiki endpoints. I guess we will have to go for option 2 then. Yes, okay. So in that case, we go to ontowiki and select our code list graph, which is this one, and ask about the concepts in this graph. And we see a description of all the continents that are available. You can, for example, ask for a comment as well, and maybe some geo coordinates like this, right? Not seeing there's the other one. Okay. So we see, for example, a description of Antarctica, which was not in our data set, but which was in our code list. There's also Australia, I guess, yeah, and some other continents. All right. So this mostly concludes our demo. There's one more part that I'd like to show you, and that is that we have this web ID functionality that Bert talked about. So we can log in, and it's going to ask for, well, a certificate to present, which is, well, my certificate for my web ID. Send that, and okay, it's going to show us a scary page because we're not bothered about full SSL security here. Then it shows us the protected page. As you can see, I've now logged in, and I can ask for my roles that I have available. And the roles that I have are, for example, administrator and user. And if I wanted to, I could now access some restricted parts, for example, which could be the publishing to CCAN, which asks us for a graph to publish, and then allows us to select all the information and input it into the application. So that concludes our demo here. By the way, the dbpedia page is now loaded, so we just had to give it some more time. And we can switch back to the presentation, actually. You can, if you're interested, try it out yourself, all of these demos. You can install the LOD2 stack as from a Debian repository, or you can download a pre-configured virtual machine from the stack.lod2.eu site. There's also a number of tutorials available at the link on this slide, which will, well, take you through the entire process that we showed you here, and other processes as well, for that matter. All right, so thanks everyone that has made this demo possible and this presentation possible, most specifically Semantic Web Company. And if there's any questions, we'll take them now.
Great. This is Martin again. Thank you very much, Karel, and thank you very much, Bert, for this impressive presentation. I think it's nice to see data workers putting their hands on the LOD2 stack and showing what is possible. So the questions are coming in. So we have one here about the stack at the moment. So maybe this is a question, if we follow the presentation, that I would like to hand over to Bert. It says, if I run a LOD2 stack using Virtuoso 6 already, and I want to update to Virtuoso 7, what exactly do I have to do?
Okay.
Karel? Yeah. So the thing with, well, as Bert said, the update manager will actually take care of everything for you. It will ask you some questions, whether you want to keep your old database or create a new one, etc. If you choose to keep your old database, however, it will actually create a row store variant of the Virtuoso 7 database, which is actually most powerful when used in its column-based column store variant. Now, you can avoid this by first creating a dump of your database, by just creating a set of RDF turtle files and the graphs that these triples come from, and then importing this RDF dump into the Virtuoso 7 system once it's been set up. There's a full guide on how to do this available on the stack.lod2.eu website, so you can find all information that you need there.
Okay, that was Karel again. Thank you very much for answering this. So I think we have a good manual for following your instructions. Then there is another one on the stack that just came in, and it says, does this run on Windows as well?
So the stack itself, and so out of the box, if you look to out of the box to install it on a Windows machine, this cannot be done because we distribute the packages as Debian packages, because this is a distribution mechanism. However, if you look to the components individually, then most of them will run on Windows too. So we have for Virtuoso, so that's one special case. You need the Virtuoso Windows build. So Virtuoso itself publishes on its own space a Windows variant build of it. So we don't distribute that one, but you can have it there. Many of the components that are in the stack actually are based on two languages. One is Java, and most web applications are jars and wars, so they can run in your Tomcat on Windows, but you have to deploy it yourself. And the other ones are PHP applications, ontowiki and on CubeViz, etc. So they run into your web application environment that you set up in on Windows. But you have to do it yourself. The best way, if you want to install it on Windows, and is actually you have your Ubuntu system, you download the application, you look to it, the part that you have interested, and you take the bits out of it and you deploy it on your Windows. That's the easiest way to get a full setup.
Okay. Thank you very much, Bert. In this case, I just would like to invite the audience, if you have more questions, then put them into the chat tool in our control panel that you see in our GoToMeeting room. There's one more about the stack, and then there are several questions around the statistical workbench. The question around the stack is, as this is a, let's say, FP7 project, is there some support for the LOD2 stack and all the components, or is it what will happen also when LOD2 project ends? So I can answer too, but I think Bert and Karel, you can answer.
Okay, so the support at this moment is in fact, if you contact us, we will answer and we will follow up. Of course, there is a layered response in this, in the sense that individual problems or situations with an individual component we will forward, so we play a central hub as stack maintainers to the different component owners. So if you have a specific question on ontowiki, does it have this extension or that, then we will forward it to the ontowiki team. If you look overall to the stack, then we have a continuation of our support in the next years with the GeoNo project, and this will so we do a transition and a handover to another partner in the GeoNo project, and so that means that the stack will be alive for the coming years.
All right, thank you very much. And I think just to make a one sentence of marketing, it's also so that Tenforce and Semantic Web Company will provide professional services around the stack and most of the components. So this is something we are planning and we're working on. So coming back to our questions, there's only one short one. Maybe I can answer it. I did not catch the URL to download the entire code from, but I think just go to stack.lod2.eu and click the download button, and then you find everything.
You will get their binaries. If you want to have the source code of the individual components is available at the places of the individual components. We don't distribute the source code itself.
All right, that was a good addition. So maybe let's go a little bit into some questions of the statistical workbench of the use case and the integration you presented. So the first one here is saying the following, a question about statistical office workbench. Do the conversion tools include the one that converts statistics in the STMX format to RDF?
Yes, there is indeed a transformation tool available. You will need the XLT files. Yes, thank you. But we'll make that available very soon.
Yeah. So our partner IMP from Serbia has been working on transforming SDMX content directly into RDF. So that is not distributed in directly connected, but we'll make it available.
Okay, that's great. And the next one here is the statistical workbench in a concrete use case somewhere. Is it in use?
So back again, we refer to our partners of Serbia, where they actually installed an earlier version and maybe even the newer version in the Serbian statistical office. So what happens there is that some parts of the statistical office, there are people who take the statistics, who publish that on the Serbian CCAM, and they use the workbench to create those.
All right. Do we have a link in the slides or some contact points? Or we can
in the use case on the stack in use page, you find a reference to the.
Okay,
I think
that's
there's
great.
also a tutorials section.
Okay. So that's good, so that we find the refers and everything that we need. So an additional question here coming in regarding the statistical workbench. It's saying, let's consider that I'm interested in the statistical features of the stack. Why should I have to install all the stack or the whole stack? The CubeViz tool standalone is enough, isn't it?
So what happens is if you install the statistical office workbench package, is actually you install only a subset that is needed, required for this workbench. It will not install you all the applications on it. So it's a selection of it. Of course, there are certain choices made. For example, I'll give you an example. There's Silk and Limes. Both are interlinking tools. We have chosen for Silk to include in this case. But you can use Limes as an alternative there, and this is a choice. And we don't make as in principle a choice as integrators between them, but this was the easiest choice we made. So you don't need to install everything, but for the workbench, in order to use and to have this whole flow, you need a minimal set.
All right, thank you very much. There's one more regarding statistical data, and 2 questions coming in regarding statistical data. The one says, related to the statistical RDF cube, can you please explain briefly what a code list is?
So a code list is actually a code list actually contains a set of RDF entities represented by URIs, which holds all the high quality and like company-wide agreed upon information about this entity. For example, if you have like diseases available as a code list, you could add to the URIs for the diseases and connect the information about the disease that you have available inside your company there, like translations and like, for example, these symptoms that I talked about. If you use these code lists, you can always connect information about diseases to these entities, so you'll always know that you'll be talking about the same thing. And because you've got complete control over this code list yourself, you'll know that the quality of the information that you have there is very high. I think that's what it means to have a code list.
All right, thank you very much. I think that explains it well. Another one, the second one that I mentioned is, I mean, it's a little bit a meta question, but it says, when does a data set become a statistical data set? For example, it says here, public administration uses a mix. So I'm not sure how we can answer it.
It's an interesting question, and it is true. I think what one case here, what we mean with statistical data set is that the core of the information is actually of statistical nature, organized according to the statistical standards, meaning in a data cube orientation. But if you look, and that's what already Karel mentioned with the code lists, and even on the observation level, you can have information about this particular observation. Maybe some observation has been constructed, some value has been constructed with partial information. And then you want to say it's constructed with partial information because we missed this and this. Or this piece of information comes from this inquiry. And this is a mix of the information. So RDF is able and capable of representing that because you can point, and because every item has a URI, you can point to it, you can connect and extend to it. But a statistical data set in the URI sense of what we're talking about is that the core of the information is represented as a data cube.
Okay, and there comes a next question a little bit, let's say linked to this one that says, regarding merging the cubes, is it possible to merge data with only partially overlapping dimensions?
Well, in principle, you can merge whatever data set. So you can try to merge, let's say, the quantities of that fishermen bring to land, together with the spending of the households in Europe. You could merge them technically. Technically, you can merge this. There's no problem of doing that. The whole problem on the merging is then, does it make sense? Can we bring this to an information cube, to a new statistical cube that will allow you get more insights in this information? Can we connect them? So if the dimensions of which your information is talking about, your statistics are talking about, are not interconnectable in an easy manner, then it's hard to do any merging in a sensible way.
If you try it, you'll probably have to use like custom Sparkle queries for that. But yeah, it is possible. You'll just have to do some custom work on it.
Yeah. So the tools and the support that you find in the Statistical Office workbench make some assumptions, namely that some data, if you merge them together, they talk about the same domain or relatively close. So they extend one dimension, they overlap on some dimension values, or more deepening of it, so they are related. There's some relationship here.
An example of what is currently not possible with the things that we have created in Statistical Office, but which could be done by Sparkle queries, is that you are merging two cubes together, and the two cubes have an observation for all the same dimension values. So you'd get a duplicate observation there. You'd have to define some way of fusing this observation, of cleaning it out. Are you going to take an average? Are you going to sum them? That's actually up to you as a specialist of the domain. So for that, you'll use a custom Sparkle query.
That's where we need the statisticians then also in the area of the domain to really work with the data. That's absolutely correct. Okay, thank you very much for this explanation. So maybe we have time for one or two other questions as we nearly have reached our hour that we have time. It says here, hello, what other methods are proposed to import data? HTTP methods with RDF serialization, for example, other file formats than CSV for manual import. So maybe a little bit an answer regarding the statistical workbench, but also the stack itself.
Yeah, so in general, so what you see in our demo is only a limited way of introducing data into the Statistical Office workbench RDF store. So we focus on and we focused on the CSV because it's easy for the demonstration, and indeed most of the, let's say, published data from the public world is tabular and CSV oriented. However, nothing prevents us to import data that's already in RDF into it, or coming from SQL databases. Then you have to use, for example, D2R to import and to connect it up. It's not core part of the Statistical Office workbench, but it's easy to extend.
All right, thank you very much. So just going through the questions that are here coming in. One more says, do you know other examples of linking statistical dimensions to external data sources except of those you gave in the presentation, for example, geographical data, so geospatial data and others?
For example, if you look to statistical in the world of statistics, and that's being published, actually they use a lot of common dimensions. One are economical sectors, NACE codes lists that are often used. You could have actually, if you look to Eurostat, there are a number of common dimensions on, let's say, household, what does it mean household, and how you split it up, and so on. That's a lot of standardization, somehow ad hoc, some are really by international organizations standardized. So that's coming
comes
from
to my
there.
mind, for example, is also census data and geospatial data, so you find lots of things here that you can link in the statistical area. Okay, one more says, which metadata on indicators on slice on units of measurement are supported by the CubeViz? That's a good one.
In principle, there's any metadata you can attach, but CubeViz might not take benefit of it in a nice visualization of it. So the RDF underlying model is able to represent it and store it, but CubeViz is maybe not able yet to deal with it. So, for example, units of measurement, this is storeable, but it's not always been represented in the way that you easily want to be visualized in CubeViz. So, and we can give a list. We can ask the owners.
No, we can do that.
Yeah.
Exactly. We can hand over also to the component owner.
It's always a question of whether you can visualize this information. I guess units of measurement would be alright to visualize, but if you want to immediately visualize like geographical information in CubeViz itself, it might be a different story. I don't know.
Mm-hmm.
Absolutely.
You can extend CubeViz as well.
Mm-hmm. That's right. Because at the moment it's mainly charts, as far as I know, that it's presenting chart types, visualizations. Okay, I got a last one here, and then I think we have to close. And maybe it's a good one also for the N4 LOD2 stack release. It says, a question regarding the migration of legacy semantic applications. What needs to be done to move existing OVL-based knowledge bases and the corresponding applications to LOD2? Is there any support regarding this scenario?
We do not have an explicit support for the application that you have built. However, most of your migration problems will not exist except the ones of moving from Virtuoso 6 to Virtuoso 7. That is where the migration effort sits. So the LOD2 stack assumes that you have a Virtuoso store, and that's how the stack is constructed in the dependencies. So if you have a data migration item to do, then it will be by migrating the data from Virtuoso 6 to Virtuoso 7. So it means if you follow the instructions that we mentioned earlier, then you can do the full migration immediately. And if you have built your applications on top of Virtuoso just on the Sparkle endpoint, actually your applications should work out of the box again.
And the same thing, maybe that I also understood this question is if I come from a different application that is not using Virtuoso, then I can import the graph in principle in Virtuoso.
Yeah,
and then
indeed.
start working with this earlier OVL-based knowledge base or knowledge graph. Mm-hmm.
Yeah. So
Okay.
it depends on that.
Absolutely. Okay. I think we've answered a lot of questions, and that is good. And there are more, but the time is running. So I would like to thank you now. First of all, a big thank to you, Bert, and you, Karel, for the great presentation.
Thank you.
Thank you.
Thank you. And I think we have one last slide, because the last thing I would like to do is to give you some announcements. So in the LOD2 webinar series, what you find next is we have fixed on the 28th of November a webinar on ORI and DL Learner. And in December we go for NIF, so a little bit more into the area of NLP. What is provided also by LOD2. And both webinars will be presented or moderated, again together with us, but by University of Leipzig, and they're showing their tools that are. Do we have them in the stack already? That is something.
The ORE is a new. There will be a new version of ORE that will be demonstrated probably, and NIF is in the stack, but it's a more standard and what you can do with it.
And the learner is available as well.
Yeah.
All right, great. Thank you very much. So you can.
Hope you enjoyed staying with us. If you need more detailed information, visit us at www.lod2.eu and let us know how we can improve to meet your expectations. Don't forget to register for our next webinar. Have a great day and don't forget.